Welcome, everyone. So, just get started, but welcome to the next session of the Azure Cloud Commanders Learning Room. So today we're going to be talking about DNS disasters, a hybrid story with the great Leo. So welcome, Leo, for coming and presenting today. The learning rooms used to be under Microsoft Teams tenant, but we have moved for those who haven't discovered the event as part of that. The learning rooms have moved within Microsoft Learn. So if you go to Microsoft Learn, go down to communities, you can see that there's like a discussion space, blogs, and then groups. If you click on groups, you can find a couple of the learning rooms listed here as groups. The one that I run is called Azure Cloud Commanders. It's open to the public. So feel free to join into the discussion, register for the events. We've got quite a few events coming in, but you have to sort of click on the event itself and then register the team to sign up for this. So there's an attend button or an interested button sort of on the event page, but unfortunately that doesn't register to these kind of events. So, but just keep them, just keep an eye on them. Yeah, we've got another one tomorrow and then one at the end of the month, and then there's a couple of more lined up that I'll be adding into the events page this weekend. But yeah, these events are all for you. So join in the discussions, comment on what sort of sessions you want. But yeah, today we've got the great Leo talking to us about DNS, which is always quite fun. This session is being recorded, so if you do come off mute or speak, just be aware of that anything you may say will be publicly available. So if just be sensitive about things that you're talking about, especially when it comes to private or your organization. It is an inclusive session, so just be welcoming, respectful. Everyone's coming from a different point of view, different reference point, so no question's a dumb question, especially when it comes to DNS. But yeah, welcome aboard. So just to close it out from the introduction for myself, introducing Leo. So Leo has presented with us actually before with security in the cloud, which is a really good talk. So I'm really interested in hearing the conversation in the session today. So thank you very much, Leo, for coming and presenting to us. I know it's early in the morning for you and late in the afternoon for me. So really appreciate you getting up early and presenting to us today. So take it away.
Yes, thank you very much. I think it's only fair because last time I think the things were the other way around and it was late for me and early for you. So
the things you do. Yeah.
Yes. And thanks again for Luke, of course, for organizing this learning room. It's always great to have these kinds of things. And welcome everybody at my talk, The DNS Disaster, a Hybrid Story. So when I was originally creating this talk, it was for some kind of conference, and they made these wonderful pictures of all the speakers, and apparently they think we're a bunch of Muppets. So we've got this wonderful picture of me, and I kind of like it. So I use this for the introduction. I'm Leo Visser. I'm from the Netherlands. I'm the product owner for automation and AI at OGD, and I'm also working as a consultant for cloud and automation and other kinds of stuff. I call myself a generalist, but I'm quite specialized still in cloud technologies. I just like to tinker with a lot of different things. I'm the one mostly working with the high-profile customers, the customers who do the bigger environments, but sometimes I also work with the smaller ones if it happens to pop up. I used to be a Microsoft MVP, but sadly, last renewal I was not renewed. So not that anymore. I'm still a Microsoft certified trainer, and love to share my passion and knowledge with all of you. Oh, and I don't wear hats, but that's just a small detail. So let's take you into the scenario I want to talk to you about today. So, like Luke said already, last time I was here, I was talking about the castle in the cloud. And this time I've got another anecdote thing to visualize this a little bit. As I am from the Netherlands, we have these things which we call polders. It's this part of the land which has been reclaimed from the sea or from a lake, and we have a big dike around it. And there's often a lot of farmlands in there and some buildings. And we also got our latest medium enterprise customer, number 38. This can be any customer, any company you can imagine. It's mostly just to make sure that we have this customer that we're gonna think about how they work. And this customer, they of course have an Azure environment. And this Azure environment looks a little bit like this. And I'm trying to go, yes, trying to go to the sheet. So in Azure, they have several different stuffs. They have the hub and spoke design, like we learned from the Cloud Adoption Framework. And inside the hub, they have some stuff like a VPN gateway, a DNS server, some virtual networks, a application gateway, public DNS zone. And they also have an on-premise environment where they have some servers. Like in the cloud, we have a lot of different things. On premise, mostly it's servers, either for databases or for programs or for core infrastructure. It's connected with each other. And we also have some spokes. And these spokes, they can have like different workloads. Often the spokes are for different kinds of applications or uses within the environment. And here we see one spoke which has mostly web apps and a storage account, and another spoke which is more like VMs and databases. This is a smaller environment. You could scale this up with more spokes, with more different things. But this is kind of like a basic environment you will see for a customer who shifted to the cloud at one point, but they couldn't go to the cloud completely yet. So they still had to keep some part on premise, either due to latency requirements or cost requirements or whatever. This is a situation I've seen a lot. These kinds of customers, these kinds of environments. And when you first look at them, they look to be set up quite okay. But let's dive a little bit deeper into this environment and see how it will react. So this dike around our land, it might have a little leak. So the water is starting to flow in. And this is to symbolize that there might be a small issue with our environment. And I think at a company, they've also discovered that something might be wrong. So when we zoom in a little bit more at just the first spoke, I've seen it happen a lot that we have these workload teams, and these workload teams, they're often responsible for deploying the things inside the spoke. So the platform team, they will be setting up the platform, they will be setting up the landing zone, and then inside the landing zone, it's the workload team who's responsible for deploying the different applications or whatsoever. This might be the same team, especially for smaller companies, but then often it's still at least separated in different deployments, where you have the deployment for the whole platform, for the landing zone, and then for the applications itself. And because inside this spoke, they have a DNS environment, they have a storage account which is used by the different web apps. They've made this a deployment, and then the web apps are also deployed by different bicep templates, Terraform templates, OpenTofu templates. Imagine what you want. And what I've seen happen a lot is that these web apps, they will be deployed by a infrastructure as code script, and they will get an IP address. And this IP address that will be used internally, or it's more like a public IP address and it's used externally. And this IP address, it has to be linked to the DNS. So inside a DNS zone, the public DNS zone, a private DNS zone, or maybe a DNS server, it has to be linked. And at one point they do this linking. And now they redeploy the app and everything goes well because it's just a redeployment of an already existing one. But I've also seen it happen where customers had to delete them, the apps, and redeploy them completely new due to whatever reason. And accidentally, they switched the order around. They did the second one first and then the other one after it. And suddenly the IP addresses were the other way around. Or maybe they were deploying it in a network, in a subnet, which has more resources in it already. And suddenly they got different IP addresses. And now the DNS is not working again. So then they also need to make sure in their infrastructure as code that they add the DNS to it, which you can do, but it could cause for some problems. And as long as you're working with an application gateway, for example, you won't have these issues because you will be adding the applications to the application gateway, and the application gateway is just one instance, so it will work. And also internal resolution will often work because it's in the Azure DNS, so the Azure DNS will change it when it's redeployed. But the public DNS, that's where the issue is. That's when it's changed, somebody has to change it. And they could try to do this with a code, but then they have to remove the old IP address and then add the new one. This causes headaches, at least. And there's also this one more issue. We have this public DNS zone, and often the public DNS zone is hosted inside the hub spoke, or in not the hub spoke, the hub for your Azure environment. And this DNS zone contains a lot of different records for many different things. And I want my developers, I want my workload teams to be able to manage this so they can change it. Like we said, when they make this mistake with a deployment, they need to be able to change it themselves and don't have to ask the platform team to change it. But I don't want them to have access to all the records in there and accidentally maybe change up a different record which they don't have access to. Now I could maybe split my public DNS zones up into different sub zones, child zones, and give these to the workloads, but then the URLs will be different, and sometimes we just need the URL of the main domain. So I've got some challenges here to make sure that everybody will be able to manage this public DNS. But if these were all the problems, it wouldn't be that big of a problem. But as you see, the water is creeping in even more. So maybe there is something more happening. So if we look again at the environment and we zoom into the second spoke, and we look at these VMs. We've got some VMs, we've got some database servers. And if you just domain join them, often it's not that big of a problem. With a domain join, we have a domain server somewhere, a domain controller, and the domain controller is often also a DNS server. And if the machines get joined to the domain, they will be joined to the DNS, and we have to make sure by using something like a private DNS resolver or by making sure that the DNS servers are set to the virtual network, that all the other machines can find these DNS servers too, so they can resolve the things. Now, when working in the cloud, eventually we kind of want to get rid of these ADDS domains. So we want to start using Entra ID more, because this reliance of the Active Directory domain is often something holding us back in our further cloud journeys. So setting them up with an Entra ID would be nice, but then we do kind of want to resolve them. And we could use the Azure names and just rely on them being joined to the Azure DNS. But sometimes you do want to kind of resolve them with a nicer name, make sure that they'll be available. Maybe you used to have them joined to a ADDS domain and you're trying to get rid of it, but you don't want to change all the internal URLs and so on. So you're making a private DNS zone. And then you need to add the machines to the private DNS zone. And the problem is you can do this with infrastructure as code, but again, it can cause some issues when we're not deploying them all at the same time, and we're not deploying them at the same time with the private DNS zone, or there's multiple things in there and everything has to be in the private DNS zone, but we don't want to deploy them all in one big template. Managing this private DNS zone can sometimes be a bit hard, and before you know it, you will have duplicate records in there, or records will be missing, or you will be having a nice Terraform template or Bicep template, and next to this also a PowerShell script, making sure that the registrations in the DNS zone are correct, and you need to make sure that everything ran all the time. I've seen it happen a lot. I've seen people make it work, and I've also seen a lot of people complain about it, that yeah, they were like, there should be a better solution for this, right? Than trying to have these things which feel like workarounds. And there's also a different issue that we want to be able to, we have these servers and they might be able to go to the internet, but I don't want their DNS resolvement maybe to happen on the internet. I want to make sure that if they resolve anything, they only resolve it internally. Because if I do it on the internet, there might be risks involved there. We'll be looking at one of those risks a little bit later. So I want to be able to control this, and I can control this with an Azure firewall or whatever. But Azure firewall is quite expensive. I remember when it was first deployed or first released, and I was looking at the price, and I first thought that they might have done something wrong with the comma and the dots, and because I was like, more than €1,000 a month, that's quite expensive. Then I understood that it was mostly for the big enterprise customers, and there €1,000 is not that much. But if you're talking about these smaller customers, it can still be quite a lot. Now we have these smaller SKUs for Azure Firewall, and many SKUs are quite suited for also the smaller customers, but especially if you're not doing that much special work in Azure, they might consider to not use this Azure firewall. Maybe they have their own kind of appliance. Maybe they are like, it's okay this way. We will always try to advise them to make it as safe as possible. Try to use the zero trust principles, like I talked about last time. But sometimes cost can just be a limiting factor. So we might want to find a different way to make sure that they can't really resolve this DNS traffic. Also, a little note, it's in a little bit more than a month, or like just a little bit less than 2 months, we will be having the default outbound access, which will be blocked. So at the moment, if you create a virtual machine in Azure and you link it to a subnet and a VNet, you will have a automatic internet access. You will be able to go to the internet automatically. But starting September 30th, as far as I know, it's still on the date. It has been moved up a couple of times, but I think this time we won't be moving it anymore and it will actually be blocked. So that means that from that day, if you have a virtual network and a subnet with machines in it and you have nothing extra, you won't be able to reach the internet anymore. You need to have something like a NAT gateway or other tools like Azure Firewall or whatever configured correctly to make sure you'll be able to go to the internet. When they were first setting up Azure, they kind of created this to make it easier for people to use it. But when you're really looking at how the networks are set up, it's actually quite weird that when you create this network and this subnet, that automatically there is this internet access. So they're kind of retconning this, fixing it finally. But do keep it in mind. And if you can still plan some holidays and you're an Azure engineer, maybe plan your holiday just a day after this if you don't want to have the headache of um, all the problems which will arrive after this. I believe I've got at least one day planned after it. So yes, keep it in mind. And if you want to know more about it, check my previous talk where I'm also talking about it, or check the documentation online. But as you see, the water is still flowing in even more. So there might be even more problems. So we have this nice connection from on-premise to the cloud because we have our hybrid environment. And our on-premise servers, they might want to connect to our cloud servers, to our cloud DNS often to make sure that they then can connect to our cloud servers. And we have this VNet peering and it's all working perfectly. Now, if you're just working with a hub and spokes all in the same tenant, in the same environment, this will often be not a problem. But it's also possible to use ways to create a private link service where your spokes could be in different tenants, or your spokes could actually also be in on-premise environments. And you can make it look like it's still just a VNet peering. But once you're using techniques like this, it is quite possible that maybe one of the VNet peerings breaks down. This can also happen when your platform engineers make a mistake, or when somebody has to make some changes to the landing zone and changes are made, and suddenly this VNet peering breaks down. Now, of course, we always want to try to fix this as soon as possible, but we do see kind of an issue here that it's not really resilient. There's a single point of failure here because now suddenly we can't reach the resources in this spoke anymore. And especially when they are publicly facing resources like these app services we had in the first spoke, people can still reach them because of the public DNS. And in the public DNS, it shows an IP address, which is an IP address of the services, and you can reach them. But internally, we often have like our private DNS zones where it also shows the IP address, and we try to route it internally. And the internal routing then breaks down. So our own people can't reach it anymore, but the people outside will still be able to reach it. And that just seems off to me. So it would be nice if there's some kind of solution for this. And the last problem, I was alluding to it already. When we have this public DNS, there is something which is called DNS cache poisoning. It's a technique where somebody tries to be faster than your own DNS server. Because we all know, I hope, that DNS is kind of this cascading system where often people go to like the Google DNS, the Cloudflare DNS, the DNS of their ISPs, for example, and these will then recursively continue, but they will also check if they might have something in the cache. The reason that the Google DNS or the Cloudflare DNS is actually quite fast is because they're caching a lot of these records and they will deliver it to you instantly without checking further along to your own DNS servers to actually get the IP address. They're like, oh, I've already got it. I've already retrieved it for somebody else. Here you go. Now, if they do make this request and an attacker is able to be quicker with the response than you are, there's some more things you need to work around. They could poison this cache and have the URL actually point to a different server than it's supposed to. And this is something we kind of want to prevent, especially if we're making applications which our customers will be using, which other people will be using to interface with our company. It's not nice if people can redirect them to a different place. Maybe they'll just redirect it to a place and have some kind of defaced website or something funny. But it's also a way to create a man-in-the-middle attack where they have a proxy in between, which will unencrypt the traffic so they can read the traffic and then encrypt it again. So it looks like it's end-to-end encrypted the traffic, but there's someone in between watching the traffic. And if there's banking data or other sensitive data being transferred, suddenly they'll be able to spy on all this traffic. So, time to fix some of these problems. So we've looked at this company and first looked like quite a decent setup, but when looking a bit deeper, there's some things which they're not issues which will pop up right away, but they might pop up a little bit later. So we have the resolution of the apps in the public DNS when the IP address can change. We have these multiple people managing the DNS records securely. We have the VMs, which we want to link to the private DNS zones. We want to be able to monitor and prevent some domain requests, some DNS requests. We want to make sure that the private DNS zones are more resilient due to the VNet peerings. And we want to prevent the DNS cache poisoning. So you could say we're quite underwater at the moment. But let's start fixing the issues one by one. So some of the things I'll show you, they are newer features being introduced in Azure. Other things are features which have been in Azure for quite some time, but it's features I just don't see many people use. And the first one is alias records in the Azure DNS. Now, my personal opinion is that one of the reasons not many people are using this is because the naming is very weird. Because if we're talking about an alias record in DNS, normally we're talking about a CNAME record. But Azure and Microsoft decided in their infinite wisdom to have the possibility for CNAME records, but also have the possibility for a record or a quadruple A record, but make it a alias record. And it's this drop-down box, the third of the third row you see, where it says alias record, and you can set it to yes. And when you do, instead of pointing the record to a specific IP address, you'll be pointing the record to a specific resource. So it will be linked to the resource ID. And if the IP address of this resource changes for whatever reason, the IP address will automatically be changed too. So especially if you have VMs which might sometimes reboot and they're in a subnet which have multiple VMs in there, there's possibilities when they reboot at the same time that IP addresses get shifted around. You can use it here. You can use it for the app services, which we were looking at before. So this technique, these alias records, I think they're quite strong and they make it more resilient and easier to manage. Because now you can just create this record with infrastructure as code or whatever, point it to your resource. And you don't have to worry about the IP address maybe changing. So let's lower the water a little bit and continue to the next one. So we have this public DNS zone, and we want to make sure that people can manage it however. And it's, I think, a feature which not many people know is that when you open a specific record in a DNS zone, you'll actually be able to set up access control on the specific record. So Azure RBAC, the role-based access control, it actually allows you to set permissions for the different records. So if you have this public DNS zone and you have some basic records in there to make sure that your landing zone works and so on, maybe pointing to your application gateway and this kind of stuff, you can make sure that these records are only being managed by your platform team. But when specific records are being created for the workloads, you could create them once and then make sure that the teams be able to then manage them. You could give them edit rights or whatever rights they need to make sure that they be able to work with it. And as a platform engineer, you don't have to worry about it that much. So I think this is a very interesting way to work with the DNS. And it's something we are not quite used to because when we're working with more DNS zones or with older DNS servers, we just have these zones and there is possibilities for delegation too. But I think this is quite nice and I would love to see it maybe being used more. Now the next one is a checkbox, which some of you might have seen sometimes, but I'm not sure many people actually check the box once. So when you're linking a private DNS zone to a virtual network, you will see the screenshot on the right. And there is this enable auto registration checkbox. I believe it was in preview for a while, but I think at least for the last year, it's kind of general available already, if not longer. I kind of forgot how long already. And what this does is when you create a virtual machine inside this virtual network, it will be automatically added to the private DNS zone. So it's kind of like the DNS delegation for a Active Directory domain. But here the Azure DNS makes sure that when you add this VM to this virtual network, it's automatically added. Now it only works with VMs. So any other resources are not automatically added, only the virtual machines. And it also only works with the primary network interface card, virtual network interface card, whatever. So if you have a VM with multiple network cards attached to it, only the primary network card will be added to the private DNS zone. If you need for some other reason multiple network interface cards with different DNS names, then the other ones you do need to add them manually. But the primary one will be added automatically. So this way you don't have to worry about it and do it with code or with PowerShell scripts or whatsoever. It will be just done for you automatically, which I think is quite nice. And now on to one of the more interesting ones. This is still a quite new feature. It still says preview here on the slides, but I believe 1 or 2 months ago it became general available. So you should be able to use this without any problems now. And this is the DNS security policies. And what you can do with DNS security policies is that you can create a kind of allow or deny list for specific DNS servers. So you link this policy to a specific virtual network. And in there, you've got rules. And these rules, they have a priority. So you can say in what order they need to be processed. And you can give them specific actions. So you can do the action allow, block, or alert. Allow and block, I think, are quite descriptive. And the alert means that it will pass the traffic, no problems, but it will audit it. So you can use this to monitor what kind of DNS traffic is actually happening. When you have a rule, you connect a DNS domain list to this rule. And these DNS domain lists, they are kind of the domains which you allow or block to be able to be resolved. So you can, for example, say that if you have this virtual network, that specific domains like ogd.nl, they will be allowed, and some other domains, they will be denied. Now, we might remember from education or whatever that a DNS name technically always has a dot at the end. And you kind of read DNS names from the right to left. This dot at the end, we almost always omit when going on the internet and so on. There's multiple sites when you add this dot on the end that they will actually have certificate errors because in the certificate, this dot is not added as a valid name. So suddenly their site breaks down. I think until recently, Google had this problem that if you went to www.google.com, you would get some kind of certificate error. But when I was trying it recently, it seemed to work. So if you want to create a list which works for all the domains, you can actually do this by just making it for the domain. So by adding just the dot, it means for all domains. So if you want to create a rule blocking all DNS traffic, you just create this DNS domain list with a dot in it, create a rule saying block traffic and link it. And now all DNS traffic outside the virtual network will be blocked. These security policies, they live on like the edge of the virtual network, just like a network security group. You could kind of see them just like an ACL as the network security group. They will be filtering this traffic. You can also use this to create some kind of URL allow listing. So if you have some kind of environment where people work in and you only want them to be able to go to specific URLs and not to other ones, you can use this to block and allow it instead of using like an Azure firewall and have some URL allow listing in there. Now, I do need to warn you, this only blocks DNS traffic. So if somebody knows the IP address of a service, they could still go there. You would need to create a network security group or an Azure firewall to block the actual traffic. But this way you can make sure that DNS traffic is blocked at least. Another interesting new feature, which is actually on the same screen we were looking at just a moment before, is this extra checkbox which has been added recently, and it says enable fallback to internet. When you're creating or when you're linking a private DNS zone to a virtual network, you can check this box. And when for some reason the resolving of the private DNS zone doesn't work, so say you have like a storage account and you're trying to resolve the storage account, and for whatever reason it gives back an error, when this checkbox is enabled, it will then try to resolve it via the internet instead. This does mean that you need to make sure that you're resolving it in the right way. I've seen many people internally use like the private link.storage.something URLs because they see that the private DNS zone is called private link.something. But when you're internally resolving it and you want to use the private DNS zone for a private endpoint or whatsoever, you don't have to add this private link to it. You can actually do it without. And internally, the Azure DNS will make sure it's added, so you'll be routed to the private DNS zone. And then when it fails, it will then automatically put you via the internet. So if you have this storage account, for example, which has a public endpoint and a private endpoint, and for some reason the private endpoint is not reachable or the DNS has problems, you can still reach it via the internet. Personally, I haven't seen many situations yet where I can use this in practice, but I think it's an interesting feature, and there'll be for sure some systems which could use this to make things more resilient. And the last one, it's something we've been waiting on for a very long time in Azure, but it's finally generally available. It's DNSSEC. If you have a public DNS zone, you can go now to the DNSSEC blade in Azure, check the box, and Microsoft will make sure that your zones are being signed, that the keys are being created. And this way, your DNS environment is signed. And this way, it's a lot harder to spoof records from your domain because now there's this extra security layer on top of it. We've been waiting for a long time on this. It doesn't cost you anything extra to enable it, and it will increase your security. So if you're a cloud engineer at some kind of customer, or you work with multiple different customers, and you want to make them a little bit happy, you can tell them, hey, I can increase your security. It doesn't cost you anything extra, and you only have to check this box. With that, we fixed all of the issues. I do want to remind you that besides the talk I gave you last time about the castle in the cloud, I've also given a talk about DNS before. It's called It's Always DNS. You can also find it on YouTube. And in there, I'll talk a lot more about how to fix some of these issues also by using a private DNS resolver. I think when you're using your Azure environment, especially when working in a hybrid scenario, the private DNS resolver is a very interesting tool to make your environment easier to manage and to fix some of the issues which you have when you're using domain joined machines and so on. Because I have a different talk about it, I didn't feel like adding it in here. So if you want to know more about it, you can look it up. And with that, thank you very much for listening. You're all awesome. Thank you for being here at this time. If you want to connect with me, you can find me on LinkedIn. You can find my blog on ordosysops.com. And I've got write-ups about these kinds of things also on there and about all kinds of different topics. It's just often my personal experiments or things I'll be learning about, and I'll write about it too. Thank you. And if there's any questions, feel free to ask them in the chat or by unmuting. But do remind that if you unmute, you will be on the recording also.
Just to give a couple of minutes for those who may want to think about questions, I just want to say thank you, Leo. It's amazing how much some of this has evolved. Like, for example, I learned something new, especially around the DNS security. I didn't know you could do it per record, which the permissions, for example, which actually is a game changer. Like, I can think of scenarios in the past where this would have just made so much sense. So
Yeah.
it's great to know that we can do that, especially the private link and the DNS sec stuff as well. It's come a long way. So thank you for sharing that with us. You're a treasure trove of knowledge.
Yeah. It's still evolving even more. Many things are still being added to the networking part of Azure. I mean, it's something we can't go without. It's the backbone for a lot of different stuff. And yeah, I'm very interested to see what new things they will be adding. I think there's still be some very interesting stuff coming to us in the foreseeable future.
Yes, I personally, I was looking at network security perimeter today with the PAS options as
Yes.
well. Because I believe you touched on it as part of the Castle on the Cloud potential talk that you did for us a while ago as well. And I know that some of the services that I'm after still not quite support network perimeter yet. However, I can see it being very useful for certain scenarios, especially when it comes to AI workloads. So yeah, it's cool to see without going full blown like private endpoints and things like that people traditionally think.
Yeah. Uh, yes, Daryl has not really a question, but more like a mention in the chat, that there's some Azure resources which don't really honor the VNet inherit DNS, but they will always use the default DNS, and that's true. It's as far as I know, if it has some kind of network interface card, it will work, but if not, it's not really working. And I believe App Gateway, for example, doesn't have the network card there, so then it's not really working, the virtual network card.
I thought it's something
Um,
you had to essentially stop and start the app gateway to pick up, but maybe not. Yeah.
yeah. This is also why I think having this private DNS resolver is a better solution, because the private DNS resolver actually lives in the Azure DNS. So if you have some kind of other DNS server you want to link, you can also use the private DNS resolver and actually link the private DNS resolver to this virtual network. And then in there, for this domain you want to resolve, point them to your specific domain DNS server. This way, it will recursively go there anyways, and you don't have to set it up as like a server to the VNet. And then, as far as I know, all resources will honor it because it will go via the Azure DNS. So that might help you, Daryl.
I'll stop the recording, but thank you very much for coming and discussing
Yeah,
and sharing your knowledge with us again, Leo. So thank you, and thank you all for attending today's session. Thank you.
and don't forget to go to all the next sessions soon or check them
Yes,
online.
and have a look at Leo's blog and connect to him on LinkedIn for any. Thank you.
Thank you very much.